Okay, so in this video, we are doing the notes for 1.5, proving triangles similar day 2. And in this video, we are going to be going through an additional way of proving triangles similar. Yesterday, we did angle, 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 and we did side, side, side. Today is a little bit of a combination. We are doing the side, angle, side, triangle similarity. So first, let's start with the definition. With this type of similarity, if two pairs of corresponding sides are proportional, and the included angles are congruent, then the triangles are similar. So as we did before, we're going to use the name of this type of similarity to walk us through the process. Again, this is a situation where if something happens, then we know that we have similar triangles. So we have to find the sides that are proportional and the angles that are congruent. If that is the case, then we can conclude that we have similar triangles and write the similarity statement. So the first thing that I'm going to do is I'm going to be looking at what I know right now. Right now I see a couple things. I see that I have two angles that are congruent, angle K and angle N. They are congruent because they have that little arc symbol that tells me that those have the same angle measurement. So when I go through and I'm trying to find a side and then an angle and then a side, I actually do have two angles that are congruent. Angle K is congruent to angle N. Okay, so that is one of the things, and I actually do like to go through and say, okay, that is an angle that I have in common, because when we check all of these things, we're going to go through and it's going to say side, angle, side on our diagram. Then I need to go through and I need to check if my sides are proportional. That's where we set up the new over old ratio and we make sure that all of the reduced ratios are the same. So I'm going to go through and match up my smaller sides with my larger sides. You can do that with colored pencils. You can do that with underlining or boxing things. So I'm going to need to check that my new over old, 6 over 8, I have to see what that reduces to. So 6 over 8 is 0.75 in the calculator. Okay, so that number is going to have to match the other side that I have, which is 15 over 20. I can plug that into my calculator as well. I get 0.75. So I have now checked that I have sides that are proportional and the included angle is congruent. Again, I checked the smaller sides. I verified that that angle is congruent with the arc. I can check this additional side. And if you look, the diagram literally says side, angle, side, side, angle, side. Because this statement is true, we have two corresponding sides that are proportional and the included angle being congruent, we can conclude that these are similar triangles. And we can write out the similarity statement. So triangle, I'm going to do, let's see, JKL is similar to triangle MNP. So again, just like we did the other day, you are just looking for a side and an angle and a side. And if the sides are proportional and that one angle is congruent, then we can use this type of similarity. So let's do some practice problems. Determine whether the triangles are similar by side angle side similarity. If yes, write a similarity statement. Remember, there are a couple situations where you have congruent angles that you don't always remember. So one of those examples is the vertical angles theorem, where if you have angles that are vertical to each other, they're congruent. That's an automatic way of having congruence. And then we also have parallel lines cut by transversals and things like that. But if I get to any of those examples where I see that, I'll let you know then. So as I look at this first example, here's what I notice. I have vertical angles automatically. So again, if we're looking for side, angle, side, I already have two angles that are congruent to each other. The hardest thing about that is writing that out. So angle FEG is congruent to angle RES. I think that's the hardest part, correctly naming those angles. Because again, I know it's tempting to just call this angle E, but like which angle are you referring to when you do angle E? So if I have FEG, that's telling me it's that top angle, and then RES is telling me bottom angle. So, you know, you do want to be careful when you're naming those. Now we have to check our sides. Again, I do want to compare sides that are comparable, so let me actually use the highlighter on this. It looks to me like 48 is my largest side on the top triangle, 12 is my largest side on the bottom triangle. So let's go ahead and compare those. I can do that in red. So let's see. I'm going to call this old, this one new. Again, you can pick that order. It should not matter as long as you keep it consistent between the two ratios. And then I can figure out what 48 over 12 reduces to. So let's see, 48 divided by 12 would give me 4. So as long as this other side also has a reduced value of 4, then we can use side angle side on this example. So let me go through. I'm going to check my other side. I'm comparing these ones because these were the smaller values on each triangle, just like we did with side, side, side. Again, I'm going to do new over old. Sorry if you can hear my dog shaking in the background. So 24 over 6. Again, that's the new value over the old value. That also reduces to 4. So we have a situation where I have two sides that are proportional, the red ones, two sides that are purple, and then I have the angle between those sides congruent. So this is a situation where you can use SAS. So I can say, okay, triangle, and then I'm actually going to do the same order as I think I did for that congruent statement. So triangle FEG is similar to triangle RES. And that one's done. Again, the way we know that is side angle side similarity, because that is what we were looking for. All right, the next example, again, I noticed some things. So I do have vertical angles on this example. That's great. I can write out the angles that are congruent because they're vertical. So angle JFS is congruent to angle YFP. Again, the letters make that more difficult than it is, okay? All we're saying is that those are two congruent angles, but the letters are how we get there. Then I need to go through and I need to compare sides. So let's go through and highlight some things. It looks to me like the smaller sides on both of these triangles are kind of on the outside. So 40 and 25, those are those smaller, the smaller sides on each triangle. And then I can do the same thing with the larger sides, just like we did the previous day when we were comparing all the sides with side, side, side. All right. Now we do need to check these proportions. So again, we're looking for side angle side. Let's go ahead and check the purple ones. So I'll do old on the left, new on the right. Again, that labeling, you can put it however you want. And then I'm going to go through and check the proportions. So I have 25 over 40 as one of my proportions that I'm going to check. And then I have this other one, it's 27.5 over 44. So let's see what those both reduce to. I can't do those in my head, so let me grab a calculator. And again, decimals are fine for this. 25 divided by 40 is 0.625. 27.5 divided by 44 is 0.625. Now, the last thing that we want to do is we want to make sure that each triangle says SAS when I write this out. So I had a side, both of the red ones. I have the angles, both in the middle. And then I do have another side on both of these, but look what's going on with this. We were told in the original example that you do have to have two sides that are proportional, but those sides also have to be touching the angle that's congruent. So if you look at our initial examples, we have a side and then an angle, and directly next to that angle on the other side is the proportional side. The problem with this example is that's actually not the case. If you look, the two sides that I have are not on either side of the angle that we were comparing. Same thing on this one. The two sides that I have are not on either side of the angle that we're comparing. And so one way that you can remember this, and it's maybe not a great way, but if you spell this out, look, we get a word we shouldn't say in school, ASS. So if that happens and it doesn't spell SAS in that order, then this is actually an example where they are not similar. Even though we went through and we checked everything, when you are using SAS, you have to have that angle between the other two. And so if that's not the case, you just say not similar, even if everything else checks out. Because again, the angle has to be between the two sides like we had in our first two examples. All right, so same process we're going to go through. We are checking sides and angles and sides, seeing if we can get side, angle, side for these triangles. So we have two parallel lines. From those parallel lines, we can probably get some angles that are congruent, I would assume. So let's see if there are any that would be good. Oh, here would be an example. So the two angles that I just highlighted are corresponding sides. So they would be congruent by definition from what we did last class period. So I'm going to write that out as the angle. CMP is congruent to angle RPQ. Let me just make sure we're still recording. Okay, cool. So that is the angle that we need. I do notice as well that these angles are between the two sides that are labeled. So if the proportions check out, side, angle, side will work. Then we're going to compare, again, the smaller sides to the bigger sides. So it looks to me like the small sides on these triangles are 36 and 22. So I can check that 22 over 36 reduces and see what I get. .611 repeating. Okay, weird, but fine. Then I can go through and check the other one. So the longer sides were 33 and 54. That's what we can check next. 33 divided by 54. See what that gets me. Also 0.611 repeating. So last thing, again, just make sure that it spells side, angle, side when you write out everything that was compared. Since my proportions are good and we do have that angle between the two sides, we can use side, angle, side in this example. So I can write out triangle CMP is similar to triangle RPQ. How do I know that? Side, angle, side similarity. If at any point I'm moving too fast, please just pause the video, okay? All right, number 4. Same thing. We're going for side, angle, side. Hopefully we can find it. So I like to write out side, angle, side. I actually have 2 angles already that I know. And because there's only one possible angle G and only one possible angle H, I can be a little bit lazy. Angle G is congruent to angle H. Then I need to check my sides. So again, I like to find the smaller side. It's 31.5 and 45 and check that ratio. So 31.5 divided by 45. Then I can see what that equals. 31.5 divided by 45, 0.7. Okay, and again, the angles are between the two sides we know about, so that's good so far. As long as our proportions match, this will be another example of side, angle, side. So now I can compare the bigger sides. 35 divided by 50, see what I get. Oops. I also end up with 0.7. So again, we've checked that we have 2 sides that are proportional. The angle between both of those is congruent. You can also write that out and spell SAS on your diagram if that helps. but this is yet another example where we have congruent sides. Or sorry, similar triangles. One thing you do want to remember though is if I'm going from purple to the angle to the red side, I need to do that on this triangle as well. So still watch out for your similarity statements. There are plenty of places to make mistakes still, even though we've been practicing this for a while, just because a lot of it is back to that notation that can be a little pesky. So triangle FGE is similar to triangle KHJ because, again, we were going from the longer side in each triangle to the congruent angle and then the shorter side after that. You can pause the video if you want to try to do these last two on your own. Otherwise, you can just keep working with me. So again, we are looking for side angle side, and actually this is comparing a small triangle to a larger triangle. So remember, in that particular scenario, they're usually going to share an angle, and that is going to be the congruent angle that we're referring to. So again, if we have SAS, the angle that these both have in common is W, and actually W is only referring to one angle, so I think we would be okay just saying angle W is congruent to angle W. The small triangle has that angle, and so does the big triangle, so it's the reflexive property that allows us to say that. Now, since I am comparing a big triangle to a small one, I do want to go ahead and remember that I don't currently know the side lengths of that big triangle, so I need to find them out by doing 14 plus 28. So that would be, let's see, 42. And then I would want to do the same thing on the other side, just so that as we are comparing side lengths, we are doing the full side of the big triangle with the full side of the other big triangle. Then I can go through and check that my sides are congruent, again, comparing small, or I guess that's the big side to the big side, which is fine. And then I can compare the small side to the small side. So again, you know, if you don't need the colored pencils, fine. But if you do need the colored pencils, there's no shame there. This is a lot we're keeping track of, and the colored pencils help. So I'm going to do, let's see, 15 over 45 and see how that reduces. That would be 1/3. Then I can do the same thing for that red side and make sure they match. And then I would be able to use side angle side if that's the case. So 14 divided by 42. Let's see, 14 divided by 42 would be, I don't know, 7 over 21, which is 1/3. Yeah, so that should also work. Oops. Exactly, 1/3. I trust my mental math. So again, side, angle, side in both cases. Therefore, triangle, and again, you know, I'm going toward angle W, I'm doing long side, angle W, and then short side. So I would do triangle QWR is similar to triangle SWZ. All right, and then the last one, again, I like to start out by getting that missing information. So the full side length of that bigger triangle would be, let's see, 34. So I'm going to be able to compare that with 27, which is that corresponding side on the smaller triangle. I can do the same thing over here. So 39, that will be able to be compared to 30. I also have an angle in common already because, again, we're going for side, angle, side, and they both have angle L. So angle L is congruent to angle L. So then let's go through and check those ratios. So 27 over 34. Let's see what that's equal to. Kind of a weird number. I'm curious how this turns out. So 0.794, and then it goes on forever. So, you know, I'm not entirely sure on that one. We'll see. And then I can do 30 over 39 and see what that reduces to. 0.769 ... So this is an example where the proportions, they seem like, you know, they might be the same. And if you rounded it, honestly, they would definitely seem like they're the same. But the decimals do matter. And the decimals tell us that that is not the exact same proportion as we would expect. So since we do not have sides that are actually proportional, we would just say not similar on this one. All right, I'm going to have the second half of this notes be in an additional video, so go ahead and watch that one next.